Problem 11.4 seems a little confusing. They introduce these weird things, but it's really not so bad. And these are actually very useful functions. They come up a lot in physics, I know, from studying physics a lot. And so what they say is they're going to define this, a function called cosine h. The h stands for hyperbolic, because when you graph them, they kind of look like hyperbolas. You'll see that. And so it's cosine, and this is kind of like cosine, and it is kind of like cosine, and this one is kind of like sine. So sine, hyperbolic, of course they're not, they're different, but they're kind of like them, they have similar properties, so that's why they call them that way. And the way people say it, instead of saying cosine, hyperbolic, or whatever, they just say cosh. So just the way it looks, right, cosh. Now this one, how do you say that? Sin or something? So people just decide to call it sinh, like it's a ch, even though it's only an h. This is cosh of x and sinh of x. And they're exactly the same, except this one's got a plus, that one's got a minus. What I suggest you do for part A is just go to Desmos, put in like this one, see what it looks like, and then change it to minus and see what this one looks like, and just draw a quick graph. Okay, just go to Desmos or any graphing thing that you like, type it in, draw a quick graph for part A. Just sketch it really quickly. It doesn't have to be perfect. Just it's the shape that matters. Like what does it do? Okay, and then part B, all you're showing is that, and they kind of tell you what to do. All you're showing is that this one squared, cosh of x squared, and you put the squared there, that means the whole thing squared. It saves you from writing parentheses. It's not the x that's squared, it's the whole thing squared. Cosh squared minus sinh squared of x, maybe I should put parentheses there, of x is equal to 1. So square this, it's good practice squaring things. Then minus the square of this one, so you like a 4 in the bottom, all that kind of stuff, and you should show that it equals 1. Okay, it's just good practice that. Now, one thing you're going to lose a lot, which is really cool, is e to the x times e to the negative x. We know that when you multiply things to the same base, they have the same base. E, x minus x is 0, so that's just e to the 0, which is equal to 1. So that's really cool. That'll help simplify a lot of things. So just remember that. If you have e to the x times e to the negative x, you get 1. You get e to the 0, which is 1. So that's really cool. Okay, that's part B. Now part C, and this is a really common physics problem. I mean, I did it when I was in graduate school, is you want to show that a hanging cable, if you hang a rope or anything between 2 points and gravity pulls it down, it makes a very definite shape. It's not a circle, right? If you hang something between 2 points, like here's your 200, you hang a jump rope or whatever it is, you hang something, it makes a curved shape, but that curve has a very definite mathematical shape. And what it is a cosh. It's a curve that looks like this. And again, it's a very common physics problem that you do when you're in grad school and stuff. And so it looks like, and this is their part C, and we don't have to figure this out. They just tell us this is the result. It looks like this number A times the cosh of x minus h divided by a plus some constant c. Okay, now it turns out h is where you put your coordinate system. H is where the center is. So if we call the center at 0, if we're going to center our coordinates at x and y at 0, then h is 0. Okay, and they say to center it, so here's our x and y axes. So here's the road. Okay, the road is the x-axis. And then here is our cable hanging here, and our cable hanging here, and it goes down like this. And we want to figure out this thing here, the smallest y value there is. They call that d. Really should be an h or something, the height above the road. But I guess they're calling, yeah, and these towers are 100 feet high. Okay, these are 100 feet high. And it's all the way, it's 400 feet to either side. So it's 400 feet, these towers are 400 feet apart. Okay, so we're going to call it x equals 0 here, and the towers are 400 feet apart. And it turns out this letter A is the length of the cable. So the length of this cable that we're hanging is 500, I think. So yeah, they say that A is equal to 500. So you have a 500-foot long cable or rope or chain or whatever it is. You're hanging it from 2 towers 100 feet high. We want to know how close it comes to the road there. We don't want it to hang too low. And this is what they do. And they hang power lines, of course. They hang power lines to 2 towers. You don't want it to be too low so people can touch them or accidentally touch them with a ladder or something. You want, or a car runs into them, a truck hits them. So you want to make sure they're hanging high enough. Okay, so the way we do this is, first we know what it is right here. We got to figure out, we know what A is, we know H is 0 because we're putting X in the middle. So we know everything but C. So we got to figure out what this C is. That's the first step. Then we can use our formula to solve what D is. First we got to figure out what C is. So what we do is you use a point that we do know. Like for instance, we know that when X is 200, right? X is 200 here, negative 200 here. When X is 200, then the height, Y, we know is the tower. Y is 100. We know that at 200, the height is 100 because that's the height of the tower. So we can plug those numbers in here to figure out what C is. So Y is 100 equals A, which is 500, cosh of X, which is 200, right? H is 0, so X is 200, A is 500, and plus C. We don't know what C is, but we know everything else, right? These are all numbers. Now, to figure out what cosh of 200 or 500 is, we got to plug that into the formula. That's what 2/5, which is 0.4. So this thing here is 0.4. So we got to know what cosh of 0.4 is. So we got to use this formula up here and plug in 0.4 for X. Okay, so it's a good calculator problem. And if you do that, let's see, so we get e to the 0.4 minus e to the negative 0.4 divided by 2. I just plug in 0.4 for X. And again, that's a good calculator problem. I did that a little earlier. And I got that that is equal to 1.081. That's 1.081. So cosh of 0.4, which means you plug 0.4 in for X here, you get 1.081. So that's 1.081. 1.0, so we have 100 equals, let's put the 500 over here. Okay, so let's put the 500 over here. So that's 100 over 500. So 100 over, oh, wait, sorry, we can't do that because we don't know what C is. Never mind. C, we have a plus C here. Okay, ignore that. So here we have 100 equals 500 times cosh of 0.4, which we know is times 1.081 plus C. Okay, so put that over here. So then C is equal to 100 minus this, because this is positive on this side, minus this side. What's 500 times 1.081? It's going to be a little bit over 500, right? I did that earlier too, and I got it's about 540.536. 540.536. That 0.081 makes it, gives you a 40.536. So that then is 100 minus that, that's negative 440.536. Okay, that's our C. Now we know the full formula. Now we know that Y, we plug all that stuff in, we plug our C in. I'm going to try to think you can see if I write the new formula up there. Y is equal to 500 times cosh of X over 500. Again, H is 0 because we're going to put our y-axis in the middle with symmetry. Minus 440.536. Okay, and then finally they say, what is D now? What is this when X is equal to 0? So when X is 0, they're right in the middle, right? That's when they're right in the middle. So what is Y, the height? Y is the height, up and down. We know it's 100 here, 100 here. That's what we used. So we plug in X equals 0 here, cosh of 0, and do the math. It turns out cosh of 0 is really nice. So imagine we plug in 0 here. E to the 0 is 1, minus e to the 0 is 1. So cosh of 0 is 0. Let me get that right. Yeah, that's right. So all it is, wait. That can't be right. So yeah, we plug in, we want cosh of 0. Sorry. This is, something was wrong there. I messed up here before. Cosh is the plus 1. Is the plus 1. So e to the negative, when I was over, oh my gosh, that's so bad. See, I need you guys here to catch me. this is a plus. This is right because I did it earlier, but e to the 0.4 plus e to the negative 0.4 is 1.081. So cosh of 0 is e to the 0, which is 1, plus e to the 0, which is 1. That's 2 divided by 2, which is 1. That's what I'm trying to say. When x equals 0, cosh is 1. So this is 1. So all we get here, so I'm going to do it right here. I'm running out of room here, but I'll squeeze it in here. So part C, the very last part, we have y is equal to 500 cosh of 0 minus 440.536. Cosh of 0 is 1. So that's just 500 minus 440.536. And I don't know what that is, but you can figure that out just in a calculator. And that would be the height. That would be the height here that's above the road. Looks like it's going to be about 60 feet, 59 point something feet. Okay, this is kind of it's a real problem. They're trying to show you how to use exponentials, how e's are actually used in the real world to solve problems. People, if you're hanging power lines, you do this all the time. You use this formula all the time. You have to make sure that they don't hang too low. But it's a cool problem using exponentials and these new cosh things and cinch things, which we'll never really talk about again. But you'll see them again if you do stuff in math and engineering. They'll definitely come up and you say, oh yeah, we did that in PreCalc. I remember that stuff. And it's not so hard. You just define them this way, and they're kind of like cosines and sines. Because for instance, this thing, and cosines and sines, it's plus sine. Cosine squared plus sine squared is equal to 1. Well, when we have hyperbolics, it's minus is equal to 1. So it's, similar-ish, but slightly different. All right, that's kind of a weird problem, but it's kind of fun. So hope it makes sense. I keep moving in front of the camera like that, like, oh, so now you can see this part, you can see this part. Now I'm out of the camera, you can see it all, but then I'm not in the camera, and then you can't see me. Which, yeah, who cares about seeing me? Okay, bye everyone.